Good morning. In this video, we're going to be talking about Objective 2, using technology to find a regression equation to model real data. So before we found a regression equation from Objective 1, if given 3 points or 3 pieces of information, and now we're going to be given real data or real world information, and we're going to do the same process, finding a regression equation, or it can be called a line of best fit as well. And so by the end of this objective, your goal should be to become familiar with and master how to use a calculator in order to do this process, all right? And so I'm going to be showing you how to use a calculator to find different things like the maximum or a specific value, and the expectation is that you would be able to do that too by the end of this video. So let's look first at this page, and on the right here is a scatter plotted graph of data. And so, like, for example, if I was given this piece of information, and I'm going to do this example in just a little bit, but the data shows participation in baseball in the US for various years, and it gives me 2 columns of information. If I were to input this into a calculator, I could create a scatter plot like you would see here. This isn't the scatter plot for that, it's just a different example. But what the scatter plot will do will roughly look like quadratic equation, or if it kind of looks like a parabola. Not the cleanest looking one, but because it looks like a parabola, we can come up with a regression equation or a line of best fit that represents a parabola, and that regression equation will help us make predictions from the data that is given in the future. We could predict like what it's going to look like 100 years from now, that type of thing. We could find the maximum amount, or what maximizes a certain process or minimizes a certain process. A lot of companies use this process to think, or to ask the question, how many pieces of whatever do I make? So let's say, how many pieces of paper do I have to make in order to minimize costs? And so they find a quadratic regression equation that helps them think through that type of information, and you're going to look at examples like that within this objective. So to begin, I've listed out the calculator steps as best I can in order to do this process. So you've had practice doing it with this objective, Objective 1. It's the same process to begin. You're going to input data into a calculator and then perform a quadratic regression function on it to find a specific quadratic equation. Now, a lot of the quadratic equations you're going to find in these examples aren't going to be as clean. If you notice, I already wrote out the quadratic equation down here from this example, and it's a whole bunch of decimal points, and the numbers are big and small and just random. And so if you see that on your calculator, it's not necessarily it doesn't mean that you're doing anything wrong. It just means that this specific quadratic regression equation to fit this data is very unique looking. Alright, so I'm going to actually do an example, this example here of baseball during various years. The first part is to construct a scatter diagram of the data and use the quadratic regression feature of a graphing calculator to find a quadratic function to fit the data. So again, if given data, like I am here, the years on the left, the participants on the right, can I input it into a calculator to make it look like a scatter plot? Something like this, alright? That's the first piece of this. And so in order to do that, I would pull out a calculator, turn it on, go and hit, and I did this here. The first button you hit is Stat and Edit. So I'm going to go to Stat, and then number 1, I'm going to hit Enter to edit, to pull up L1. And then if you see, they've put data into L1 and L2. Again, this is a different example, so I'm going to go to the example I'm working on. And my L1 is going to be the years, and if you notice, they've zeroed out the years, and so year 0 in this piece of information is 1900. And so this 87 is technically 1987, 1990, 93, 1998, 1999, but for the sake of this, we just want to put the last 2 digits into our L1. So I'm going to go ahead and do that. 87, 90, 93, and then as I get done with this, I'm going to put the millions of participants into L2. I've inputted into my L1 and L2 all of the information necessary, and so one of the very easiest mistakes to make is just you inputted a number incorrectly into L1 and L2. And so as you're doing this process and you do not, if you don't get the y equals equation I have in red right here, chances are you just inputted something wrong into one of the columns. Now, at this point, I'll go back to this page. It says after you've edited and you've inputted into L1 and L2, you're going to go back to stat, hit calculate, and then choose option 5, quadratic regression. So I'm going to hit stat again, go over to calculate, and then I can either go down to number 5 or just hit the number 5 and then hit enter. So I want to run a quadratic regression. Now, at some points your calculator might not look exactly like this. It might bring up a list of options that say L1, L2, store something, and then calculate. So you'll just go down to calculate and hit the same. So you'd scroll down to calculate and hit enter. I'm just going to hit enter here, and it's going to do the same thing. So if you notice, it has given me my quadratic function or line of best fit that would fit this data. So as I put this in a scatter plot, which I'm about to do, it would fit this data the most accurately out of any quadratic function. And this equation, if you notice, we're going to start inputting numbers into it. It'll help us think about different things that exist within it, like, well, what's going to, based off of this table or this information in the quadratic function, what's the participation of baseball going to be like in 150 years? We could make a pretty educated estimate off of that. So at this point, you would need to write this down. All right, so that's what I did in red. This ends, or it almost ends, step A, or part A. I wrote down the function y equals, and then you do need to include, to be as accurate as possible, and on the test you need to do this too, you need to include every decimal point, all right? So that's why I wrote in red right here, every decimal point that I see on my calculator, because eventually we're going to input that into y equals and graph this thing. So that ends this part, and now I'm going to actually construct the scatter diagram on my calculator as well. And so, all right, now to make the scatter plot. So this isn't on your sheet, the blue in part A. So please write this down. You'll need to know these steps, and you need to reference this sheet if you forget how to do these steps. In order to make the scatter plot, you hit y equals, so again, write all these steps down. You hit y equals, so I hit y equals, and so I think I was at this page right here, this part of my calculator screen. So I hit y equals, and then I input equation into y equals. So this equation we found with the quadratic regression function, our feature of your calculator, you write that into y equals, and so I have already done all that, and I know that it's tedious, and I know that it might take a little time and there's room for error, but please just pay attention to detail and put every number within the decimal points into the calculator, because this is how to get the exact function that we need, and this is how to get all the points on the test. So I've inputted that into the calculator, and then I turn on plot 1. All that means is I'm going to scroll up. If you see there's plot 1, plot 2, plot 3 up here, I'm going to scroll up to plot 1 and hit enter. Now plot 1 is highlighted. It means that plot 1 is on. All that means is that we're going to have a scatter plot, or that gives the calculator the idea that we're going to make a scatter plot out of the L1 and L2 lists that we've inputted into stat. At that point, we're going to hit graph. Nothing is going to come up because the default graph, the XY axis, is a window of -10 to 10 and -10 to 10 on both the X and Y axis. And if you notice, this data does not fall in that window. This is 87. 87 is way over to the right. So I'm going to hit zoom. Zoom is the button you would hit to change anything. Sometimes you're going to need to zoom out. There will be times during this process you're going to need to zoom out because your window still isn't big enough to capture all the information. But I'm going to hit zoom number 9. So zoom stat is the 9th option. I'm going to go down to zoom stat and hit enter. That just is going to give us the basic statistics window. And if you notice, we're now hitting the plots. So we've made a scatter plot, and we've also included our regression equation within the scatter plot. So if you see, this is a parabola shape. It's not a full parabola, but it fits it within the window. And if you notice as well, there's 5 pieces of data. There's a X value, a Y value, and so at the X value of the year 1987, the Y value up here is 15.1 million. at the x value of 1990 over here. It's 15.5, and 15.6 is the highest. And if you notice again, the regression equation doesn't hit all the dots, and that is okay, again, because this is just a line of best fit, meaning that is the best estimate that we have to model this data given. So at this point, you have done everything to do step A, or part A in this problem. I have made the scatter plot, I have found the regression equation that is the line of best fit for the information given. I didn't say this, but please make note that the year is the x values and the millions of participants are the y values. So the input is the x value. If I input 87 into my function here, it would spit out something close to 15.1 million. Same thing on the calculator. Alright, and so in the next video I'm going to show you how to use the regression function to estimate the number of participants in 2000. So if you notice, this data only goes to 1999, so we're going to start utilizing the calculator to make estimates of the data as it continues on and what the max and min and those types of things might be. So in the next video, look for how to do part B. Alright.